in the last lesson, we did some simple stuff like this, where we said, look, clearly x must be 3, because that's the only way that I can get 8. And the main focus for today is on solving exponential equations. And that's an example of an exponential equation. So let's look at something a bit more tasty. Now, if we look at solving this, I want to know, what is the first major problem with this question? What makes life difficult? I want to know what makes life difficult. So Stephen, I think your hand is up. Are you? Oh, I think you just up from earlier on, so I'm going to press mute. But if you have a comment, just raise your hand. What is the first thing that makes life difficult? I want to know from you, if I said find x, where would you get stuck? CM Tanda, what do you think?
So I basically think that 125 is, and 1 is a negative, and 2 needs to be changed so that they
Yeah,
have the same page.
I agree with you. The 125 and the fact that it's on one side, I feel like, were you thinking of what I thinking was going across to the other side like that?
Yes, sir.
Okay, let's do it. I agree with you, because then at least it feels like the recipe for solving exponential equations is there, because I know that this 125 can be broken down into 5 to the power of 3. See if you can solve this exponential equation from here. If you get stuck, I want you to raise your hand or make a comment. If you can do it, I want you to do it and then put your answer in the chat. So let's see if you can do it. Okay. Now, what I say to my students is, don't forget about the insurance policy. I'm going to wait for some answers or for some questions to come through. Okay, CM Tanda's got a answer. Let's see if anybody else has got a similar answer. I was thinking the 3 needs to get multiplied, so I get that. And then this must be equal to that. So let's have a look at what this looks like. And so then we get, what's that going to be? Let's make it a little smaller. So then we get 10 equals 4x. And if I divide both sides by 4, I get 10 over 4 equals x, which is 2.5. So I get, and which is the same as 10 over 4. So me and CM Tanda agree. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow it. Who else? I want to know how everyone is finding that. Okay, so we're good. Okay, so the main technique that we've used so far is if we have exponential equations, we want to get it so the base is the same on both sides. And then we want to break things down into their prime bases and use the laws of exponents that we've been talking about in the last 3 lessons. And then we use the logic of comparing. When we've got two bases that are the same, we can say the powers are the same if the whole things are the same. So let's go to some slightly harder ones. Let's have a look at this collection. So I want you to try and do number 1. So let's try and do number 1. Make it nice and big. So number 1. And I also want you to try and do number 2. And I want you to try and do number, actually, let's do 1 and 2. 1 and 2, and then we'll go from there. Bearing in mind what we learned in the last question, and as always, it's your responsibility to ask a question if you're unsure, because, yeah, you have plenty of airtime, and so I'm going to assume you're doing okay unless you step forward and ask a question or make a comment. Oh, let me make it so you can see what's going on here. We are trying to do the ones in yellow. Okay, so now, what I think is important is that you realize that you have to put brackets around the x plus 3 so that you know it's one thing, and you have to put brackets around the 2x minus 1. If you don't do that, when you multiply things out here, it's not going to go well for you. And then the other thing is there needs to be a 3 to the 1 there. See if you can get to the answer for number 1. I want to see the answer for 1 in the chat so that I know students have got there. Or I want to see a question. Okay, let's see what we get here. I think we should get, I know it seems like it's the same answer again, Fatu. I see what you mean. Let's see if how we go here. 6x minus 3. So that really is the tricky bit. So because it goes 6x minus 3, and this is 2x plus 6. But then on this side, we can just have 2x plus 7, because the 1 and the 6 get added, equals 6x minus 3. And now we know the bases are the same and the powers are the, well, and the whole values are the same, so the powers must be the same. So we get 2x plus 7 equals 6x minus 3. If I bring that across to the other side, I get 6x minus 2x. So I get 10 equals 4x. I divide both sides by 4, and I get x is 10 over 4, or 2.5. So far 2, I agree. Did anybody else get 2.5, or do you see how I got to 2.5 there? Give me a thumbs up or thumbs down, or a happy face or unhappy face. Just let me know in the chat how it went for you. Okay, so far 2 feel. Caitlin, how did it go? Simtanda, are you with us, or are you feeling a little bit like, oh, that wasn't so good? While we're waiting for them to get back to us, let's have a go at number 2. What's the key step for number 2? What's the key step for number 2? Oh, brilliant, Simtanda. Number 2, I kind of wish there was a 3 on the other side. Is there anything that we can do to deal with that? So far 2, same base. Yep. Any ideas? So what Fatu, I think, is saying is we really want this to rather be a 3 to something. And the key idea is that it must be to the power of 0. Yes, because 1 is, anything to the power of 0 is 1. So that's a clever way of getting around this problem. Find me the answer to number 2. Find me the answer to number 2. Okay, so Stephen has an answer. Let's see if anybody else has the same answer. So we have a 6 and a minus 6. So it could maybe be there's 2 answers, but let's look. 2x minus 12 is 0, which means 2x is 12, which means x must be 6. And so the correct answer is x must be 6. Okay. Let's do one more from this exercise. I want you to solve for me question 4. Find the value of x for this exponential equation. Use all the ideas that you've learned so far and see if you can do this one. Step 1 is to get the bases the same. So I think most of you would have done this as step 1, which is a good idea. What do you have to do next? This is an interesting question, number 4. Why is it interesting? Why is it interesting? I feel like I have to multiply the bracket out, and then I have to bring the 2 to the other side. Now, what is interesting about this equation? It's a quadratic. Yes, it's a quadratic equation hidden inside of an exponential equation. So what do we do to solve quadratics? Well, there's a couple of ways. The one is if you've learned the quadratic formula, or you can factorize it and then find the answers using the zero product property, or you can use the quadratic formula, which I haven't taught you yet, but some of you might have learned about it. And that formula looks like that. Now, this one is not a hard one to factorize, so I think I would just factorize it. Get me an answer for number 4.
1.
Number 1. I think one of the
1.
answers is 1.
1.
But there's another one.
1.
Excuse the pun. So x, and we have, what are we going to have?
Positive. Sorry.
Yeah. Okay, so we have 2 and 1, and then we're going to have plus minus, and then we are going to have x minus 1 is 0, or x plus 2 is 0. And so, Stephen, I think you were correct. You're going to get x is 1, or x is minus 2. So those are my 2 answers. All right. So that was a bit of a tricky one, but I think you've got it there. Okay, so that is the basic exponential equation that's pretty common in tests and exams. However, there are some harder varieties, and I want to show you a harder one just because obviously you're in the standard class. And so in order to get above 50, the type of question you might encounter is something like this. Now, why is that question a little bit more difficult than the ones we've been doing so far? I want to hear from people of the room. Why is this one a bit harder? What makes it a bit more difficult? And maybe it's easy just to raise your hand to describe. What do you think, Caitlin? Any ideas? What makes this scary to you, if I had to say? I see Fatu is keen to give us a description. Fatu, what do you think?
So I think it's because there's like a minus.
Yep, minus makes life difficult. Yes, it
Yeah.
does. Any ideas how to get around the minus, or any technique we could use?
So we need to break down the 2 numbers and then take out a common factor.
Oh, well done. Yes. So I think you are onto something. But you've given us such a big hint there. I think that is enough for a moment. So if we do that, or maybe one more thing, why, I heard factorize. What technique of factorizing would we use to factorize this side? What technique would we use to factorize? So if we think about,
So we take out
yeah,
a common factor of 3 to the power of x.
perfect. Exactly. And what's going to be in the bracket? What do you think?
3 minus 1 over 3.
Yeah, so I'll even put it like this just to start with, but we all know that in fact, this is really just another way of writing 3 minus a third. And here's my 216. Okay, now, if I go from there, I think I've actually got 3 to the x times 3 minus a third is 2 2/3. And that's going to be equal to 216. And then, you know what? I'm going to change it from a mixed number. I'm going to change it to an improper. And if I change it to an improper, I get 2 times 3 is 6, plus 2, I get 8 over 3 equals 216. I want you guys to find me my answer. We still haven't got there yet, but what is the answer for x? Give it a bash. Okay, welcome, Atlichan. I see you are joining us. Welcome. Okay, what is our next step going to be? So our next step is going to be to bring this 8 over 3 to the other side. And you know what I'm going to do that? I'm actually just going to multiply by the opposite of this, which would be 3 over 8 and 3 over 8. Because if I multiply by that, I'm getting left with just my 3 over 6 and then x. And then probably I could just use my calculator here to get the number. So what number am I getting here? Or I could divide 8 in, but yeah, what do you get here? What number am I getting here? Is it 81? So 216 times 3 over 8, or yeah. And if it's 81, then we get 3 to the 4, and then my answer must be x is 4. So that was quite a mouthful, huh? That was, and if we look back at what made it like more difficult, what made it more difficult was needing to factorize in step 1, take out a common factor. But before we even did that, we actually had to split it. So we had to split it into these 2 pieces. Okay, let's see if I can find one more like that before we go on. Let's have a look. Okay, let's do the number 5 here. I want you guys to solve for me number 5. Can you solve number 5 using these techniques you've learned today? Find me the value of x. And then we're going to take a break. You're doing well. So think about what Vatu was saying in the previous question. What technique can we use that Vatu kind of showed us? Okay, let's have a look. So Fatu's got 1. Well, let's see. If I, oh, that's too big, eh? 5 to the x. Now, plus 5 to the x times 5 to the 1 equals 30 is the one thing that I think we were doing there. And then what I can do is I can take out a common factor of 5x, and I want to know what goes in the bracket. And I think it's going to be 1 plus 5. Let's just make sense, because there's a 1 sitting here, and then this is 5. So then what I have is I have 5 to the x times 6 equals 30. And then if I bring the 6 to the other side, I actually get 5 to the x is 5 to the 1. And so then x must be equal to 1. And so I agree with that. Okay, so we have covered, in this first part of the lesson, we've covered basic exponential equations, and then we've covered slightly harder ones. And then we're going to gradually progress over time in the second part of the lesson. But we've done some quality work. And so what I want to do now is I want to see you turn your cameras on. I want to see all your lovely faces, and I want to do some exercise. Otherwise, our brains are not going to benefit from the second half of the lesson. We need to take care of them so they take care of us. So cameras on, let me see those faces, give me a wave. And then I want you to just stand with me and stretch, because you've been sitting and you're human like me. That means that your bodies need a bit of a stretch. So I want you to just stretch to the left. There we go. I want you to stretch to the right. Okay. Oh, that feels good. Shake out the arms. Shake out the legs. Then I want you to start rotating a little bit from your hips, just very lightly. And as you relax, you'll feel that you can go further. Oh, that feels so good. You are missing out. You should be getting FOMO if you're not twisting like this. Okay, then let's roll our shoulders back to loosen them up. Maybe they're getting a bit tight from sitting forward, so we're just going to roll them nice and loose. And then we're going to roll them forward. Okay, then we're going to do tricep stretch. So up like this, stretch the tricep. And then we're going to go to the other side and stretch. Okay. Oh, okay. I feel so much more like my body is just happy with me for taking the time to have a break. Now, I want some blood pumping in your body. And the way we're going to do that is jumping jacks. So make sure space around you is clear. This is a jumping jack. And we are going to do 15. I'm going to start in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, and I can feel my legs and my arms. And I think it's now time to take a break and let the blood pump around my body so that I can feel refreshed for the second part of the lesson. So we did our jumping around, and here is today's puzzle. You have to tell me what is the triangle equal to based on what is here. What is the triangle based on what is here? Okay. Circle is 5, so Siamtanda, I agree with you. I can see very quickly that this must be 5 because it's the only way that could be true. Square is 2. Let's see if I agree with that. I do agree. The square is 2 because that gives you 12. And that means that. So what is a triangle equal to? I feel like today's one was a little bit, maybe I should have made it a bit harder. Maybe I'll find another one. What is the triangle going to be equal to? So Bodmer says that must be done first, and that must be done first, and then I minus. What is the triangle going to be equal to? Okay. So I think that 5 times 2 is 10, and something times 5 equals 5. The only way that could work, oh, Simtanda, I agree, is if this is a 1. So this has to be a 1, and that has to be a 1. The triangle has to be a 1 to satisfy this riddle. So the answer was 1. So Simtanda, to you goes the glory. Well done. Okay, so in the previous part of the lesson, we were dealing with exponential equations. Now, we are going to come back and deal with some other types of ones, but for now, I want to look at some other equations called, let me zoom out. Apologies if I'm giving you a headache. Come back to those ones. I want to look at equations with rational exponents. So this is a little bit different. What is different with a rational exponent equation is that the exponent is no longer like up here. The variable is the down here on the ground. The power is the exponent. But what I really want to do is I want to get the x by itself to be x to the 1. And so I have to find a way of undoing the power of a half. But remember, the power of a half is the same as a square root. Now, what undoes square rooting? What undoes square rooting? What undoes square rooting? Anyone in the chat? Atlechan, Sichle, Fatu, Caitlin, Siamtanda, what do we think? What will undo square rooting? I think the opposite process to square rooting is to square. And so what we're going to do is we're going to square this side and we're going to square that side. And another way of thinking of squaring is to say it's raising both sides to the power of 2 over 1. Now, what happens when I do that is that the 1 times this cancels out and this cancels out. And I get x to the 1 equals, what is my x going to be equal to? What is my x going to be equal? What's my final answer? It's 9, yes. And we can check this by going to our calculator and saying, what is 9 to the power of half equal to? In fact, we don't even need a calculator. We can actually just see it. We know it's just going to be 3. So 9 is definitely the correct answer. So the technique we use is we don't multiply. We raise both sides to the power of the reciprocal of the power that's there. Now, what a mouthful, eh? But when I say reciprocal, all I mean, let me show you this again. Here's 1 over 2. What's the reciprocal? It's just 2 over 1. But if I raise one side to that, I must also raise the other side. So let's try this technique out on another question. So I want you to find me the answer to question 3. Solve that using the technique that I just showed you. Now, you have to undo 3 over 4, or x to the power of 3 over 4. And you need to think about, how do you want to do that? If you get stuck, raise your hand. Okay, Siamtanda, let's see. So I think the first thing I would do is raise this on both sides to the power of 4 over 3. Okay, next problem. I need to now figure out, life is good because I've made this cancels out with this and this cancels out with this. But I need to know what the answer is here. And I think what we should do is make 8 2 to the power of 3. And then there is already a 4 over 3 outside. But remember, this 3 is 3 over 1. So that cancels. And I get 2 to the 4. And 2 to the 4 is 16. So I agree with you there. Anybody else get 16 like CM Tanda? Everybody happy with that? Okay, let's do something a bit more feisty. Fantastic, fantastic. Okay, let's do, apologies, I'm jumping around, but I'm choosing the ones that I think will bring the most interesting questions. Let's do number 3. So I want you to find me the value of x for question 3. Fantastic, Atlegang. Fatu, that's brilliant. Now, let's see if you can handle the next step up in difficulty. How does this one go? Okay, Fatu is, you're giving lots of good tips, Fatu. Okay, Fatu has said, divide both sides by 3. And the reason I think that's so fantastic is it takes the headache away here. And so now this becomes actually just solving the equation. Let me see if I can find a space here. So the new question is actually just to solve that, which is a lot like the one we had before. Now, what are we going to get now for our answer? Well, we're going to raise both sides to the reciprocal of the power, which is going to be 3 over 1. And so what is my final answer going to be for x in this question? You guys are smashing these ones. I think I'll take it up another notch in the next question. But I just want to see what everyone else gets. I don't want to move too quickly and get too excited. So Atlichang agrees 64. Anyone else? So I think that it's just going to be 4 to the 3, which is really just 4 times 4 times 4, which is 64. Perfect. Okay, everyone. Now, because you're doing so well, I'm actually going to have to jump around because I want to find you something a bit more difficult. Now, what you notice so far is all of these questions that I've looked at, they all have odd numbers at the bottom. But if I deal with something that has an even number, it can actually be that I have 2 answers. And I want to show you, let's have a look here. 2 over 3. Okay. Look, 3 over 2, 3 over 4, 3. Okay. Let's have a quick look here. Actually, you know what? Let's go back to this one. Why go? Let's go back to this question over here. I want to try and do this one. So let's try and do 2b. Now I'm jumping around a bit, but I just want to see if you can handle a question like 2b. Can you handle a question like 2b? It's a little bit harder, but still not undoable. Let's see if we can do that one. So my tip is to look at 4 and 8 and ask, what can both of those be broken down into? And I think that they both can be broken down into powers of 2. Now, how that helps me is up to you, but just think about how that might help you. Okay. Oh, the light is going down here. So I think that this 2 gets multiplied by this, and this 3 gets multiplied by this. So all we're really going to get is x plus 1, x minus 3. And then on this side, we're going to get 2 to the power of minus 3x. Give me a thumbs up if you follow my logic to that step. Just give me a thumbs up if you followed me so far. And then I'll give you more time, but I just want to see that you got to that step, because the next step is going to be to say, look, this is equal to this. Okay, so you just keep swimming and you see if you can get me an answer. So I think we need Atlichang, you've got it coming. Eh? This is another one of these ones where a quadratic pops out of the exponential. And so there's different ways, but you can totally feel it coming. And so I'm guessing it gets down to standard form at some point. So 2x squared. And so because we're running out of time, I'm going to speed up a little bit. But my standard form is, because the minus becomes a plus, so minus x minus 6. So what you need to do for me is to solve that quadratic to get me my answers. So step 1 was to change bases. Step 2 was to, let's go to Fatu. Fatu has hand up and we can have a bit of a chat. Let me see if I can unmute you, Fatu. Let's have a go. What do you think, Fatu?
When I simplified it, I got 2x minus 3 and x plus 2.
Yeah.
I'm not sure if that's correct. It's
2x
all equals to
plus
0.
4x minus 3x. So I would, let's just check. So 2 and 1 minus 1. And now we got 3. We need to get to minus 1. So 3 and 1. This is going to be a plus. This is going to be a minus. Yes. So 2x minus 3, I agree with you. And now we know 2x minus 3 is 0, or x plus 2 is 0, which means x is 3 over 2, or x is minus 2. Now, I went quite quickly there, but I just want a vote from the class. Did you follow my thinking there? Did you follow my thinking? Because I want to squeeze in one more question for today that is another type of question that I want you to get familiar with. Caitlin, Atlichang, Siamtanda, how are you feeling? Let me know, because I want to have a look at this one over here, which is a little bit different to everything else we've done. And so before I move to that, I just want to get and you can give me an unhappy face if you like, but I just want to feel for the group how you're feeling about that question. Okay, while we wait for feedback, I want everyone to look at C, and I want to ask what is different about C compared to all the questions we've done today. Because this is we're getting to the harder types of exponential equations. So we've been working our way up, and now we've worked up to one which it looks completely different. And I want to know from you, what do you recognize as being different? And then I'm going to give you a structure you can use to help you through this question. What looks rather tasty about C? I'll zoom in so it gets the complete attention it deserves. Something that is getting my attention is this. What is this problem? Can you all see that there is double the power here of the one over here? Give me a thumbs up if you can see that there's a double power to this one over here, and that's weird. That's a bit different. Okay, now this is the trick you use when you see a double power, or if you see a negative power and a positive power. We use what's called the K substitution method. But before we do that, I want you to first understand with me. Give me a thumbs up if you can see why the thing in the green block is exactly the same as the question above. All I've done is I've split this 2x, because if I multiply it, I get back to 2x. But like this, I like this because it allows me to focus on the 2 to the x. So again, happy face, sad face, thumbs up, thumbs down. Let me know how you're feeling. Because this is the last question of the day. And I want to make sure you're with me. Okay, here is the magic trick. So you've recognized it's one of the funky questions where there's a double power, and you've split it up like this, and you say, let 2 to the x equal k. Now, if 2 to the power of x is k, then k squared minus 3k minus 4 equals 0. Take a moment to look at that and think about it. Tell me if you agree or disagree that if I let 2 to the x equal k, k squared minus 3k minus 4 must be equal to 0. All right, fantastic. Now, I want you guys to solve for k for me. Solve for k, and I think k looks like a trinomial to me. So see if you can find me a value of k. See if you can find me a value of k. Kind of feel like this must be k, that must be k, that must be 4, that must be 1. And so I think this must be minus and this must be plus. And then you can do the extra brackets, but we can basically see k is 4 or k is minus 1. Okay, now here, ladies and gentlemen, is the sneaky clever bit. Remember when we started with this and we said 2 to the x is k? Well, now we're going to say 2 to the x is 4, or 2 to the x is minus 1. Give me a thumbs up if you understand the connection between this and this. Give me a thumbs down if you don't get the connection. All right, now, here's the first problem. This branch over here, if I raise a positive number to something and I get a negative, is that possible? So 2 times 2 times 2 times 2, am I ever going to get negative? No. There is no way that you can take a positive number and multiply it by itself and end up negative. So this part of the question is no solution. So that part, no answer. But if I look at this part, what does x have to be? What does x have to be? The only way that this can work is if 2 to the x is equal to 2 squared, in which case x must be equal to 2. Fatu, let's go to you. I see you have your question up there. Yeah, how can I help you?
Is it not supposed to be 2 to the power of 2x is equals to 4?
No, but that's a great question. If you look at where we defined this, right? We defined 2 to the power of x to be k. And so when we made that substitution, k was 4. And so that's why it has to be 4. Are you with me?
No.
Not. Okay, don't worry. We can go through it again. So let's go back from the beginning. Are you happy that 2 to the x squared is 2 to the 2x? Are you happy with
Yes,
that bit?
sir.
Okay,
Yes,
now,
sir.
are you happy with me replacing this bit with k, and it becomes k squared minus 3k minus 4 is 0? Are you okay there?
Yes, sir.
Perfect. Are we okay with the factorizing and the finding the value of k? So when we do this bit, are we okay?
Yes, sir. Yes, sir.
Okay, so now the only thing we can do is say, look, 2 to the x is k is 4, which means 2 to the x must be 4. Now, 2 to the x can also be minus 1, but we've decided that that's not possible, so we reject that. And so the only way this can be true is if x is 2. Okay, now, what I want you to do, this is by far the hardest question that I've done, and I will start the next lesson by going over this. But what I want you to do is re-watch this recording and just go over this last bit again. This is called the K substitution method, and it's for harder exponential equations. But we've run out of time for today, so let's just revise what we did. We started with simple exponential equations. I'm going to come to you now, Siamtanda. Then we did equations with rational exponents. We're going to come back to those ones as well. And then we did harder exponential equations, and then we finished with the hardest one, which is called the K substitution method. And that is it for today. That's a lot.